So one of the first things I started off with was this idea called space brick.
This concept that we have here, it deals with how different panels come together to create one single modules.
Living on Moon and Mars, which is further away from us, where the delivery of goods from Earth is going to be more and more problematic.
How it would be working or how it would behave in the microgravity conditions.
Building colonies on the moon, growing lush crops on Mars, and manufacturing in space for Earth's requirement. Sounds like a leaflet out of an extraterrestrial Hollywood movie, doesn't it? But the scientists at the Indian Institute of Science in Bangalore are working towards making this distant dream a reality. Hello and welcome to The Print. You're with me, Soumya Pillai, and today we'll be speaking to some of these scientists who are working in their labs on advancements that are going to take India's space programs leaps and bounds in the coming years. Stay with us for the next few minutes to see what kind of work is happening in these labs.
India's space agency ISRO is preparing to send the first Indians to space through its much awaited Gaganyaan mission. By 2040, we also plan on landing the first Indian on the moon. But in the labs at IISc, researchers are working for a future where humans will be able to live in space. The architecture is ready, the material is finalized. In fact, some of these experiments are only awaiting a launch date to be tested in space.
Hello and welcome to The Print. We have a very special guest with us today, Professor Aloke Kumar, who's with Bangalore's Indian Institute of Science and who is doing a range of experiments which will advance India's space program and technology in the coming years. Much of the work has already been done, and we're going to speak to him about what has already happened and what is in the pipeline. Thank you for speaking to The Print, sir. If you could just tell us first a bit of an introduction about the work that has already happened in your lab when it comes to advancing space tech in the coming years.
So thanks, Soumya, first of all, visiting the lab. It's good to have you here. See, I came back to India in 2017, and before that I was a professor in Canada, and I was leaving a very well-established lab, moving back to my own country. And at the time, I thought, okay, let's make some difference. Let's do something that will excite people. As India has had such a long, good history with space, uh, and at the same time, the whole idea of space habitation, etc., was catching up with people. So I thought maybe I can contribute something with my knowledge. I'm a mechanical engineer, so is there something the mechanical engineer can do for this kind of thing? And yes, there's plenty of things to do. Uh, Actually. So one of the first things I started off with was this idea called space bricks, where we take lunar regolith, the sand that you find on moon, the fine grainy powder that exists on the surface of the moon, and a similar thing for Mars. So they are called lunar and Martian regoliths respectively. So this is the most abundant material that is there, and if humans go and settle onto these heavenly bodies, then we'll have to start using materials that are locally available to us. I mean, we have been doing that, to be honest, for a very, very long time. And when the Mohenjo-daro Harappa people settled in the Indus Valley, they utilized the local soil to make the first bricks. Right? These are the first cities of humans that we were established. So similarly, I thought, okay, maybe there's something we can do. So one of the things we started looking at is taking these different powders. So behind me, you can see there's the different types of lunar soils and Martian soils that are there. And we started preparing a process where we could mix bacteria with the soil and sort of cook them, in quotes, and end up with a brick. And it took us a while to be successful. It turns out that the lunar and the Martian soil are not very favorable to Earth bacteria. So when they go there, they're basically aliens, right? Our bacteria are aliens on Mars and Moon, so they're not very hospitable environment. So we have to do something to make it hospitable for them, and that's the process that took us a long time. That's the interesting science that it took. It also helped me understand more about my own planet. For example, Moon doesn't have any clay, right? And clay is the source of life. Clay is the part of soil that holds water, and this is what gives Earth its unique properties over all other rocky barren planets. So we took that and we developed a process where we could. So, for example, if you see this brick, uh, this is quite hard. This is made out of a lunar soil simulant where we mix bacteria, etc., together, and we were able to cook it in the lab. We published quite a few papers on the technicalities of it, but end product is a hard structure like this. So you see, this is quite strong, and since then we have been looking at different aspects of it. Um, and it was around this time when the astronauts were also they had come back to India, and their program was going on, and me and Shubhanshu, we got talking with Group Captain Shubhanshu Shukla, who's right now in the US. Wish him the best of luck from the lab and everybody. So we got started talking about what else could we do, and we should take this thing further from the lab. And these are all nice experiments that are happening in the lab, but what is it that we can do? Take it a little bit further. So we see these guys ended up enrolling. All the four astronauts ended up enrolling in IISc for their masters. Shubhanshu enrolled with us for his master's thesis work, and one of the things that he's working on right now is the idea of there's human habitats that we can make on the moon. There's a lot of work to be done. Of course, this is much more work than a single lab can do. But we are putting together some of the first concepts. Things will change, it will evolve. But most of it, I hope, what it will do is it will excite the young students that are out there to think beyond what is taught in their classrooms, to dream beyond. I'm a mechanical engineer, and I've been doing a bit of biology in my lab. I never studied biology when I was a student. In fact, I never saw a bacteria till I finished my PhD. I did not know the difference between a bacteria and a virus properly. So there's a lot of things that can be done, and there's a lot of interesting possibilities for all students. So we are looking into all these different aspects, from space breaks to making habitats, but also to making next generation satellites, which will be very different from the satellites that we are used to today, which are purely electronics. Like all the communications and Earth observation satellites that you hear about, those are all electronics based satellites. But in the next generation satellites, you'll also have manufacturing happening in space. So the satellites will become more and more complex. They'll accommodate different thing functionalities that were not there before. And our lab is working at the forefront to make some of those also.
So while what we have here is an scale down model for showing the entire architecture system, which shows like how the different modules are can be joined, and then how it can expand it at a larger scale. This prototype, that this concept that we have here, it deals with how different panels come together to create one single module. So we have this kind of joineries, and we have this kind of panels. So this panel, when collapse, they can be easily stacked up to provide maximum the minimum volume possible, and these can be stacked up in a rocket payload pairing, and then it can be sent out to space. Upon reaching the destination, these panels can be assembled together with the help of this kind of joineries. It goes something like this, and the whole volume can be deployed over there.
Yeah, and one of the key USPs of our design is that this can fit in a payload of a very small payload. So, for example, the payload that ISRO is currently using, the GSLV and the PSLV launches, we don't need to wait for technology to catch up, or we don't need to rely on any other countries' space capacities to be able to do this. So, it very much aligns, this whole vision very much aligns with what ISRO is planning for India for the next 10, 20 years, is where we want to set up a permanent Indian base, a space station and a lunar base on extraterrestrial soil.
They are not stopping at just building in space. For humans to survive, they must also understand how microorganisms behave and grow in space. So, when the first humans fly to space on board India's Gaganyaan mission, a batch of bacteria will be their co passengers. You heard that right. Kumar's lab is preparing to send India's first biological satellite to space to study how it behaves and grows in microgravity conditions.
So what we've built here is going to be India's first biological satellite. and world's first speaker satellite to hold an active bioexperiment in space. Essentially, we are interested in seeing how microgravity affects microbial growth in space, and this has been a long-standing goal of Aloke Lab for the past 5 years. So we have moved from a lab-on-chip paradigm to actually building payloads for ISRO and now for India's first private launch with Skyroot. So this is a PQ60 based satellite where we are doing microbial analysis in different aspects or different versions of this. Yeah.
So the whole idea is to make this space bricks in the Mars and Moon habitat itself. So what we are trying to do is we are doing in situ construction. So we have the regolith over there, but we need the bacteria from here. So in order for the bacteria to consolidate and for it to produce the carbonates and thus form calcium carbonate, it needs to grow properly. So the main thing would be we need to understand how this bacteria would work in the extraterrestrial environment, how it would be working or how it would behave in the microgravity condition. That is where Manas and the Skyrot now can be useful. So we can this bacteria produces spores which are resistant to very high temperature. So we essentially use the spores and we can check how when if we provide suitable environmental conditions for it to grow in the satellites, how it would be growing under the microgravity and the extraterrestrial conditions. Once we get data on this, whether it is how the metabolic activity of the bacteria would be in such environments, we can then use this bacteria to produce the space bricks on the moon and Mars habitats itself.
Space agencies around the world are working towards colonizing space, and India is not far behind. Especially after the Chandrayaan 3 landing on the moon and India's new space policy, the opportunities are endless, and scientists are ready.
The entire space industry has been going through a big change for a quite long time. This was mainly the endeavor of state-run enterprises, be it India, be it the US, be it Russia. It was basically NASA in the US, it was Roscosmos in Russia, and India obviously ISRO, and they were taking the lead, and they've done fantastic job laying the groundwork for such a difficult enterprise, right? But now we are seeing a change. We are seeing a democratization of this. We are seeing a situation where we are going away not from just what was scientific exploration to a phase where we think we might be able to have colonies out there. And if we have colonies, we have to have broader participation. We have to have participation from different aspects of the society. They have to come in. We have to all think. So with this entire democratization of space that is going on, now we'll have research laboratories also coming in, starting to participate. Obviously we are also already seeing a participation from companies, from the private industry. So this is now going to be a mix of what I believe the future holds is there's going to be a mix of the state-run enterprise, the private entrepreneurs, and research labs like us coming into all doing their own thing, complementing each other in their own way. We often deal with the low TRL tech, just for the readers, TRL is technological readiness levels. So a lower technological readiness level is usually what is there in the lab. The higher technological readiness level products are products that are tested for field trial with field trials and are that can be deployed outside. In the domain of space, there is so many different ideas that have to be now tested for humans to be able to live. Living somewhere is a very, very complex task. We have done that well on IS in the International Space Station, but living on Moon and Mars, which is further away from us, where the delivery of goods from Earth is going to be more and more problematic, it's going to create its own challenges. We'll have our own learning curve, and each portion, like the research labs like ours, the state-run enterprises, and the private entrepreneurs, I believe all three have their different roles to play in this. So, what our labs are doing, for example, are thinking of very futuristic problems like how do you design a house on the moon and on the Mars. These designs will go through many different iterations, and finally, before the ones that can be flown out, they might look slightly different also from the ones today. But it's important to put the problems out. It's important to start looking at it from a scientific perspective. Uh, this also disseminates information within our general public. People in my lab, for example, they come all from traditional backgrounds, but they're all trying to do with their own skill set. They're trying to do pieces of this puzzle, and that's exciting in itself. And I hope this happens at a much broader level. In India, there are already research labs, different research labs that are participating. There are some research labs at IISc. There are quite a few others at IIT Kanpur, IIT Madras. Are also trying to do some very good work. There are others also. I can't mention for the brevity. I can't list out all of them, but all of them are now starting to think and contribute in their own way and bring in their own scientific experience into this. And I think this is it's an exciting time over the next decade that we are.
It's true that India only began its space program when the US had already landed its first human on the moon. But India is not willing to live with this disadvantage in the coming years. And it's labs such as these which are aiding and pushing India's dreams to becoming a space superpower in the coming years. Thank you for tuning into The Print. You were with Soumya Pillai for The Print.